welcome to virtual memory discussion for operating system. So what is virtual memory? So virtual memory is memory management techniques where secondary memory is used as if it were part of the main memory. So we know that our central processing unit or our CPU can only access the main memory, and it is also the among other storage, it is the fastest storage. So virtual memory is used when there is no enough memory in our RAM, so it uses other storage in our unit as if it is part of the main memory. So today, most personal PC come with a large 8 gigabits of RAM, but sometimes this is not enough to run several programs. So we know that some program uses heavy on RAM. For example, those programs which have a lot of graphics. Yan. So this is where virtual memory comes. Virtual memory pre-ups RAM by swapping data that has not been used recently over the storage device, such as hard drive or solid state drive. So our VM is important for improving system performance and for multitasking and using a large program. Yan. Virtual memory was developed at a time when physical memory, also referred to the RAM, was expensive and computer have a finite amount of RAM. So before, we only have limited storage for our RAM, 64 MB, ganyan. So ngayon, yung mga RAM natin umaabot na ng 8 gig. Ayan, pwede pang doblehin pa. So that is the case. With virtual memory, a system can load larger multiple program running at the same time, enabling each one to operate as if it has more space without having to purchase more RAM. So how virtual memory works? So virtual memory uses both hardware and software operation. So when the application is in use, data from a program is stored in the physical address using RAM. A memory management unit or MMU maps the address to the RAM and automatically translate address. So the MMU can, for example, map logical address space to corresponding physical memory. So parang nangyayari dito, yung nandun sa RAM, parang front na lang yun nung isang portion ng address. So, pag pinuntahan yung address na yun sa RAM, so pupunta na siya ngayon doon sa specific physical address. So, pwedeng nasa SSD or hard disk. So, if at any point the RAM space is needed for something more urgent, data can be swapped out of RAM into a virtual memory. Ayan. The computer's memory manager is in charge of keeping track of the shift between physical and virtual. So, ang naka-in-charge dito is si memory manager. If that data is needed again, the computer MMU or MMU memory management unit will use the context switch to resume execution. So, yung tinatawag natin na context switch, so siya yung nagsaswap between the virtual and the physical memory. So, pag kailangan niya na nandun na siya, virtual memory, so siya yung magta-swap. So, ito yung, si context switch ay may napaka, laking role. While copying virtual memory into physical memory, the OS divides memory with fixed number of addresses into their page file or swap file. Each file is stored on disk, and when the page is needed, the OS copies it from the disk to main memory and translate the virtual addresses into real address. Yan. However, the swapping of virtual memory to physical is rather slow. This means using virtual memory generally causes noticeable reduction of performance because of swapping. Computer with more RAM are considered to have better performance. So, ito nga yung solusyon natin nung mababa pa yung mga binibenta or napakamahal pa nung mga RAM na matataas yung storage. So, until now, we still use virtual memory in our computer kahit na mataas na yung mga RAM natin. Kasi pataas din ng pataas yung memory requirements ng ating mga software application. Okay, we have types of virtual memory. A computer, MMU, or MMU manages virtual memory operation. In some computer, the MMU hardware is integrated into a central processing unit. So, in other hardware, integrated yung MMU hardware sa CPU. And CPU also generate virtual addresses space. In general, virtual memory is either page or segment. So, page or segment. So, yan yung further discussion for segment in paging is found on the module available on the learning management platform. Okay. So, with the use of virtual memory, let's know the benefit of using or having this virtual memory as features of our operating system. Okay, so it can handle twice as many addresses as main memory. So for example, yung main memory mo is 8 gig. So twice, that would be 16 gig. Ayan, 16 gig, pwede mo nang i-handle. It's enable more application to be used at once. So, pwedeng sabay-sabay lahat ng application. Kung mabilis naman yung CPU ninyo, yung processor, so, kailangan niya ng maraming storage while nagpa-process. So, with virtual memory, it can handle more operation all at once. So, it pre-application from managing shared memory and save user from having to add memory module when RAM space run out. Ayun. Pagkulang na si RAM. So, it has increased speed when only a segment of program is needed for execution. So, mas mabilis pag konti lang naman yung segment ng program ang nag-execute. It has increased security because of the memory isolation. So, ayan, enable multiple larger application to run simultaneously. So, parang ganito rin lang. It has not need external fragmentation. CPU use is effective for managing local partition workload. Data can be moved automatically. So, yung context switch. Page is in the original process can be shared during the fork system call. So, alam naman natin yung system call operation that create a copy of itself. So, hindi na magkakaroon ng conflict between the use of resources kasi magkakaroon na siya ng copy of itself. Okay, what are naman the limitation of the virtual memory? Although the use of virtual memory has its benefits, it also comes with some trade-off worth considering, such as application runs slower if they are running from virtual memory. So, since virtual memory, hindi mo direkta in-access yung RAM from RAM, yung physical memory natin, pupunta pa siya sa page file, tapos dun sa ating pinaka hard disk. So, nagkakaroon ng transition between the two. So, kung halimbawa, kailangan niya yung files dito sa RAM, kasi dito sa RAM, nakakonect siya kay CPU, diba? O, habang nagpa-process CPU, sasabihin ni RAM, oh, I need the file. Tapos, pupunta naman dito. Okay, pupuntahan na anong address nitong ganitong file. So, pupunta dito. So, nagkakaroon ng transition. That is why, it became more, slower. Yan, nagiging mas mabagal because of using virtual memory. But, yun nga, ito yung trade-off. Kasi, kung konti naman, unless hindi na natin mararan yung program kasi nga kulang yung memory. So, another trade-off is data must be mapped between virtual and physical memory, which require extra hardware support to address the translation, slowing down a computer further. So, yung pag-map yung sinasabi natin kanina. The size of virtual storage is limited by the amount of secondary storage, as well as the addresses schemes with the computer system. So, the size of the virtual storage is limited. So, ina-allocate lang naman kasi natin yung virtual storage. Hindi natin pwedeng iubos lahat kay virtual storage. So, for example, meron tayong hard disk na ang size niya is 10 gig. Then, kukuha lang tayo doon ng virtual storage. Hindi natin pwedeng kunin yung buong 10 gig kasi ginagamit din yun ng ating mga file. Okay, trashing can occur if there is no enough RAM, which will make the computer perform slower. Trashing. So, ibig sabihin, trashing, it's a mechanism na dinidelete niya yung laman ng RAM. Kasi, kailangan niya ng, di ba yung RAM, magiging na lang siya, parang from RAM, ilolocate niya from page file. So, paano ngayon, pag puno na yung RAM? So, ang gagawin naman, ang mechanism naman na gagawin is trashing. I-delete niya tuloy lahat ng content ng RAM. And then, para siyang nagre-restart ulit. So, that makes the computer perform slower. It may take time to switch between application using virtual memory. It lessens the amount of available hard drive space. Oo. Siyempre, kasi nga kung meron tayong 10 gig, ang baba naman ng na to. Kung meron tayong 10 gig, tapos yung 2 gig ilalagay natin sa virtual memory, so meron ka na lang na 8 gig. So, yun nga. You can only use the 8 gig. Kasi yung 2 gig mo ay virtual memory. Okay, let's summarize. Virtual versus physical memory. So, virtual uses a segment of physical memory. Kay RAM, it is exactly the physical memory. Ayan. Virtual RAM is slower. Ayan. Pag sinabi pala nating virtual RAM, nasa loob po to ng HDD o kaya solid state drive. So, yan yung virtual RAM. Yeah. And then, virtual RAM uses paging while RAM uses swapping techniques. Limited by size of the physical memory while RAM is limited to the size of the RAM chip. And then, virtual RAM does not have direct access to CPU while the RAM direct access to the CPU. So, just remember that the only memory storage that is under or can be accessed by our central processing unit is the RAM. It is the only storage. So, kung halimbawa, nagkokopya tayo ng file from flash drive to another flash drive. So, ang nangyayari doon, from flash drive to RAM, then RAM to our another flash drive. So, kasi yung operation nangyayari lang na sa pinakamalapit or sa physical memory. Hindi pwede doon sa mga ibang memory storage. Dito yun pwedeng ma-access ni CPU. Another, limited by the size of the computer hardware. So, kay RAM naman, can add RAM by installing more RAM chips. So, yun naman yung advantage. So, pwede tayong mag-add depende sa available na slot ng ating computer or desktop or laptop kung ilan yung available na slot. So, if we already have 2 gig, so, pwede, usually, mayroon yung dalawa. So, you can have another 2 gig. So, meron na kayong 4. Kung gusto mo, 2 gig plus 4. So, meron kang 6 gig. Ayan. Pero si hard disk, papalitan mo, medyo mahal. Kung ito, let's say, ito nasa 500. Ayan, yung 2 gig to, sabi na 500 to 700. So, bumilis na yung computer mo. Pero kung ang gusto mong dagdagan is si hard drive, so, makakagastos kayo niya ng mga 2K to 5K. Ganyan. Siguro yung 1 terabyte is already on 5K. Okay, so that is the simplified discussion for virtual memory.